Here I am one more time to present in front of you in my KINK classes channel. As such, in the previous videos we have discussed about the different kinds of graphs. In the last video we have understood about the bar graph. Now today in this video we are going to learn about the next kind of a graph that is called as a histogram. So for that, first of all, let us understand what is the histogram. So histogram, you can see on the screen that a histogram is a graphical display of data which is using a different heights. In a histogram, the each bar groups numbered into the some ranges. The taller bars show that more data is going to fall in that particular range. A histogram, what is the histogram displaying? A histogram displays shape and a spread of continuous sample data. So whenever the data is given in a continuous form, or we can say a continuous interval, then we can say it comes under the category of histogram. But as such, you know that in every situation we do have some weaknesses. So hence we have some weaknesses in the form of histogram. So histogram have many benefits, but it also contains some weaknesses. The first one is that a histogram can only present the data, but it can also mislead us. For an example, if we will take, if we are using too many blocks, suppose if we are using too many rectangular blocks, that can be a very difficult for the analysis point of view. It will be a little bit of a difficult task to us. So while too few can leave out of the important data, so some of the bars can be left out, important data can be misleading. So here is one example which I am showing to you, a histogram of a multimodal. You can see here the some data is being not mentioned here, so that can be a misleading here. Might be the data which is not mentioned in the circle might be an important data which can mislead the graph. So, but as such, the histogram is also having some important characteristics also. So here is the characteristics of a histogram. So generally a histogram will have the bars which is always of an equal width, although it should be remembered, although this not the case when the class intervals vary in the size. That means a very big size is given. The bars are equal of width and it always corresponds to the equal class intervals. So by using those class intervals only, we used to construct a histogram. Remember, while the height of each bar corresponds to the highest frequency of that class, it represents, so that particular class is represented by the height of that particular bar. Okay, so but we find a little bit of a difference between a histogram and a bar chart that I have discussed in my previous video. So here is a difference of a histogram and a bar graph or a bar chart. You can see in the histogram, the blue graph, that's the histogram, you can see here that it does not have any gap. You can see here no gaps are present between the two rectangular bars. But whereas if we talk about the bar chart or a bar graph, you can find out the gaps in between the two rectangular bars. So that's the main difference between a histogram and a bar chart. Now let us draw some of the bar graph, we can say histogram, sorry. Let us draw some histogram. So here's the one question written here. We have to draw an histogram. The class interval they have mentioned here as 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, and the frequency is given to us is in 30 in this column, 98 in this, 80 in this, 58 in this, 29 in this, whereas in this it is a 50 frequency is given. So the way of constructing the histogram is nearly equal to that of a bar graph only. So what we have to just first of all mention here is that the class interval which is representing along the x-axis and the frequencies are representing on the y-axis, that should be the suitable scale for this. So here's the histogram drawn of the above table. You can say the scale is also written, the y-axis of one big division is equal to 10 units. See, we have started with 10 to 15 because our table is here from 10 to 15, then 15 to 20. You can say it's a continuous table, hence you can see there is no gap between the two rectangular bars, and the frequency is taken on the y-axis. The measurements you can see in between 10 to 15 it was 30, in between 15 to 20 it goes to the 100, and in this way 100 or 99. In this way we have constructed a histogram. Let us take a one different kind of example in which you are going to understand one more thing. Here's the given below a frequency distribution table of 50 students in which 140 to 145 class interval, 145 to 50, and here 150 to 155, 155 to 60, and 160 to 165. The frequency ranges from 8, 12, 18, 10 and 5. We have to draw a histogram using the above data. So x-axis will be suitable for the class, limits will be of an x-axis, suitable scale we are taking, and frequencies are going to be get represented on the y-axis with a suitable scale. But you can see the data is starting with 140 directly. So how we can take the x-axis? So here you can see now there is a one thing is being mentioned here that we call as a KINK line that I'm going to explain you after this solution. So what is a KINK line is representing to us, that I'm going to explain. This is the KINK line. You can see a marker I have done here. This is a KINK line, and in the x and y axis all the data is represented. So why we have use this KINK line? What is this KINK so called as? So students, listen it properly. A KINK is a curve, would be a point where the curve is a continuous. From this point only where the KINK is ending, the interval will become continuous. Yet the first derivative that we call as an gradient, it is not continuous. That means before, in between 0 to 140 in the above data, it was not continuous. So just to curvature would be the infinite, remember, at a KINK. So at the point of the KINK, the curvature will be infinite because the direction changes a finite amount, because after that the direction is going to change to the finite values. After the KINK line, it will be a continuous histogram representation on the graph paper. So I am sure you have understood that how we can represent a histogram with the help of the KINK line, and as well as a simple representation of a histogram on the graph paper. But just solving the two questions will be not enough for you. So here I have given you a home task to you. The two questions I have placed for you, at least you can solve these questions and represent it on the bar graph in the bar channel with the help of using a histogram concept. So one question is given, we have to construct a histogram using the above data, in which the monthly school fees in rupees is given and the number of schools is given here. And in the second question again you have to draw one histogram, but you should remember, I am sure you have understood in the question number 2 that you have to use a KINK line because the data is starting with 450 to 500. So hence you have to just mention a KINK line in that particular histogram, because the daily earnings of the 30 drug stores are given in the following table. The earnings is starting from 450. It's not starting with the smaller values, but in the question number 1 the values are smaller, so no need to draw a KINK line in after the 0 marker. So mention the graph properly and draw the histogram heights with the proper frequency measured in this. And if you face any problem drawing the histogram, any kinds of a question, please comment me in the comment box, so at least I will get the notification and I will clarify whatever the doubts you're having. In the upcoming video we are going to learn about the next kind of a graph that we call as an circle graph or a pie chart, and after that we are going to learn the last kind of a graph that will be called as an polygonic graph. So for that you have to just wait few days, then I'm going to explain all the things regarding the pie graph and a polygon. So hope you have all understood it. Kindly subscribe my channel and press the bell icon. Thank you very much.